Ja, opent hem?
Ja.
Ja. Goed. Is dit het?
Ik denk het wel.
Ja, ik denk het wel.
Yes. Welcome everyone to the, I don't remember how many meetups we already organized in Belgium. Today we have two presenters, Wouter and Cindy, both very agile, very dedicated Mendix developers. And they will be explaining how they implemented a multi-workflow, so multi-dimensional workflow in Pharma. So Wouter will take you through a part of what we call the theory behind what's a workflow and how far can you go into a workflow. He will then expand with a technical demo on how they implemented it. And Cindy will show us how they actually did show it to the stakeholder, business users, and so on. So without further ado, I would say, Wouter, take it away.
Thank you very much. Thank you very much. Thank you very much for having us and for attending. As Jeremy said, I'd like to take you along. If this is working, it doesn't seem to be working. Let's double check. No, it's really not working. Then I'll use my mouse, which should work as well. Which is not working either. Interesting. And we'll just do it like this. The entire laptop seemed to freeze. Restart. Where is it? Yeah, it's doing something. So let's try again if the other one works. Yeah, yay, it is. Okay, so first off, I'd like to take you along on a bit of background regarding the theory, but also regarding what exactly this workflow does, so some business context. Then I'd like to share some of the ideas that we came up with during the construction process, some of the challenges we faced, especially regarding modeling a context domain, that's number 3, but also modeling the workflow itself. And finally, because we're really talking about a multi-dimensional workflow with a workflow and a workflow and a workflow and a workflow, there's a challenge with representing the data. So we'll show you some UX patterns. And then finally, one more thing, which is also the thing, right, in IT presentations. So again, this is for a pharma app, and that means that there's a hefty legislation and audit requirement. So consider, for instance, a pharma manufacturer creating some kind of pill that has to be shipped to a consumer. Then we probably all want that pill to be safe. And in order to achieve that, we've instigated lots of measures and laws that actually make sure that the pills that are produced are inherently safe. So again, we have to basically adhere to all of these audit and legislation requirements, and that makes this a bit more tough to implement. We're talking about a global workflow, meaning someone in New York could trigger it, and then the next person in Paris could pick it up 5 minutes later, followed by someone in Beijing. So it's literally global. And in this case, it's a web-only app, so no mobile component to it. So first off, you might be wondering, what is a workflow? Right? Maybe a couple of questions. Who of you has built a workflow app? Yeah? Or maybe modeled a workflow? Okay. Yeah? Some of you there, right there. Who of you has built a Workflow Mendix app? Okay. Let's go to the definition of workflow before we move on to what that means in Mendix. Workflow is a noun. the series of stages that a particular piece or type of work passes through from the beginning until it's finished. And I think the key word in here is a series of stages. What does that mean? For me, it means this. We have one task, then another person doing the second task, meaning a handoff, and then a third task, again done by someone different. That for me is a series of stages with handoffs. That for me is a workflow. So we have 1 to the nth of tasks, 2 to the nth actors. So that could also be a machine, by the way. So it could be that the machine does something first and then hands it off to another user. And these tasks occur usually at different times. So there's an asynchronous nature. It's not all happening in series. And finally, I think key here for workflow is that there are handoffs, especially for Mendix workflow. Otherwise, you could use a microflow, something like that. So what then is a multi-dimensional workflow? For me, again, the same principle goes. We have a task, but now suddenly we get extra dimensions. So here we have parallel tasks, and these tasks could even have subflows in them. So we're getting deeper and wider in a sense, and that starts to become multi-dimensional. So parallel sub-workflows. So I'd like to take you along to a bit of the actual business problem that we try to solve. So it happens in a pharma company that one of the suppliers instigates a change in their processes. Imagine we're producing a pill that requires aluminum powder, right? And it comes in batches of 1,000 kilograms. And then suddenly the supplier decides that it has to be taken down in half. And then suddenly we're getting aluminum powder in batches of 500. You might think that, okay, is there really a difference? And that's actually something that has to be inspected to see what the consequences are for supplier change in the entire production line. Usually the pharma client will then get a supplier change notification email. That's this event. And then our flow starts. So we get this email and the secretary picks this up. This one person, and she inspects this email and says, I think there should be 1, 2, 3, or 4 divisions actually picking up this, this email to maybe inspect what the consequences are for our production lines. So that will trigger an exploration flow. So at least 1, but it could be 4. 4 exploration flows. And then you might wonder, what are those exploration flows? First off, a quality manager will inspect that supply chain notification email, and then basically fills out a couple of questions. And then there will be a reviewer if there is impact. So the quality manager might say, hey, this doesn't affect our processes, then no review. But if it does, then it will have to be reviewed by a second person. And the reviewer can actually say, hey, you did something wrong, so go and do it again. Then there is modification required. But if not, then we'll just basically continue with the flow. So that's the exploration flow, which can happen 1 to 4 times. So the result is that we know that there may be an impact in a factory. For instance, we have to have a different hopper that can take 500 kilograms of a box of something, aluminum powder, instead of 1,000. Or there might be global impact, or maybe both. That's basically what we ascertain with this step. So 1 to 4 of these. Next up, and you see that happening immediately, so once an exploration flow finishes and there is global impact, it immediately starts. So let's see that again. For each of these, if an exploration flow finishes with impact, we immediately start a global flow. So then the question is, what is a global flow? It looks a bit similar actually. So again, we have a quality manager making a plan and setting out a number of tasks. And then we get this task subflow, which can be done 1 to 10 times, in which actually the same person executes these tasks. And in this case, it's done asynchronously, so not at the same time, later on, meaning that they actually become a workflow. So in a sense, there's a handoff. And finally, there's a global closure for the same quality manager, and this is the process. This can happen in total 1 to 4 times. So meaning we can have 40 concurrent tasks at the same time already in this flow. So the result is that we know that the global impact has been checked and we're adhering to legislation, big check mark, and we have an audit trail to prove it. Next up, it's also possible that there is local impact, and this has to be checked for each factory. In this case, there were 10 different factories, so it might be that from exploration 1 we get this impact for site A, and then the next one for site B in Antwerp, and this one might say there's impact in B as well, and also in C, etc. So we could have between 0 and 10 local flows, depending on what the outcome is of this exploration series. So a local flow, I'll inspect that in a bit. The key here is that we have to wait until all of these exploration flows are done. And then we tally up the number of factories, and then we only start 1 local flow per factory. And it looks like this. So basically there's a quality manager who sets out tasks. These are picked up by the local SME. I'm sorry for the lighting, it's a bit poor, so I hope you'll forgive. So up to 10 tasks, and once these are done, the local QM inspects the results, and finally there may be a local sign-off done by another QM, so that's why we have a different color. And why we get this, so you see it's optional, actually it's set up here at the beginning that we decide if we need this extra sign-off. So it depends on the factory and on the process in the factory. So the result is that the factory's been checked and we're again conforming to legislation, and we have an audit trail to prove it. So that's sort of the business issue here. I hope that's clear. So we could literally have hundreds of concurrent tasks. That's really multidimensional, I think. So the question is, can Mendix do this? And then how? And basically that's how we came up with 4 challenges. There were actually a lot more, but I'd like to take you along in a little bit of a journey right within Mendix. Let me just change my screen so that you will be able to follow, and then just duplicate. Should be visible right now. Is it? Yeah, it is. So the lettering is a bit small, so if you can't read, I'll be happy to zoom in as much as we can. Actually, I'd like to start with this. So let's imagine this workflow with task number 1, task number 2, and then there's a log at the end. This is really a series of tasks. And let's say that we want to make this multi-dimensional. So how to model these parallel optional flows, right? So that's actually what we can do in Mendix by having an attribute in a data container, an entity that we can see right here. And right within here, I have an attribute called task count with enumeration values 1, 2, 3, and 4. And I'll be using that in this flow. So let's have a decision right here. I'll drag that in, and then I'll select that enumeration, so it's in the context, task count, and then you see it automatically generates these paths for me. And then we already have our first branching. So this is optional, so it's either 1, 2, 3, or 4. And basically in task 1, we decide which one it's going to be. And right now we need to model that this task 2 is actually going to appear here. So how do we do that? So if we have 2 tasks, then obviously we need some kind of parallel split, and we need that here as well, and we need that here, and I think we need 3 here, so let's have 3 paths, and then 4 paths here, so that's 4, and then we can start cutting and pasting. A very rudimentary form of parallel workflows. That's it, basically, and this will actually work for now. So this is the first of 2 ways in which you can model parallel workflows. there are a couple of pros and cons in this sense. So one of the pros is that you can actually see what's happening here, right? We're modeling it out and you can take a look at it. You can see that there are actually 4 options. One of the downsides of doing it this way is that, well, if we want to extend this further, then we have to do a lot of scrolling, and we have a lot of copies of task 2 already. So what if I want to change the name to task 2.3? Then I need to do that here as well, task 2.3 and task 2.3, etc. So you see, it becomes a drag pretty quickly. There's a way to work around this by using a subflow that we can drag right in. So I'll just show you what the subflow looks like. In this case, it's a workflow with just a single task 2. And then likewise, we can just use those subflows in all of these branches. So that will work. But again, there is a negative aspect here, or a downside, because what if I want to have specific data container for this flow that is set apart from this one? Right now we have a very simple domain model with just a single data container. But if we have 4 people working together who all need to input data, then I might want to have something like this, where we have a survey, right? And the survey is done 4 times. And then we can say there's a value for question A. So that's this. But this is impossible, this relation. This is not compatible with the current setup. So, and let me show you what is compatible. There's only one way actually. We have to draw 4 one-to-one relations. And those we can actually use. So I'll show you again. So if I now want to show that new survey that belongs to one of these one-on-one relations, that is what I can do by using an expression and saying, hey, go to this one-on-one, and then here is the first one. Let's see. I need to change the context still, but this will actually work. And I can show you an actual example of our application, where here you can see we have a number of groups to a supplier change notification with the first, the fourth, here you see it, right? So it says fourth. This is probably second, so we actually had to do that 4 times, and likewise we could actually model these. So there's a negative aspect there again, because we have a lot of duplication in our domain, and it's not nice to look at. And well, could we do that better? There's an alternative, and that's the second way. So I'll go back to this application. I'll click this away, and that is basically this one. This is the same flow. So again, we have a task 1, then we trigger a microflow, and we start 1 to 10 tasks, and then basically we're logging at the end. So again, if you look at this one, where we do this, right, this is exactly the same. So let me show you how it works. This is a bit of logic called a microflow, and in this case, this is what we're doing. First off, we're pausing the main workflow. Changing the workflow state, pause workflow. Secondly, we're going to loop over a number in this case, and that number can literally be the number of tasks. That's an integer in this case. So that could be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So, and we're going to iterate over that in a loop, and that's what we're doing here. So we're saying, okay, if 1 is lower than the number of tasks, then we're going to do this. And then at the end, we're going to up the iterator, iterator plus 1, and then we're doing it once more, and once more, and once more. So if we have the number 10, then first time, we're calling a workflow. Then iterating, then second time calling a workflow. So likewise, we can call sub-workflows. This is unlimited basically. We could call 1,000 workflows. Doesn't really matter. And we won't have the issue that we have right here with the scrolling, right? And all of the duplication and all of the one-on-one relations. And actually, indeed, we can use a one-to-many relation that I just showed here. So this is actually possible to be used with that second paradigm. There's a second thing we need to do, but before I show you that, there's something else that this way of working requires you to do. So basically we have 10 workflows now that are a slave, but we have to connect them to that main workflow. So by using this previous paradigm, Mendix Workflow does that all for you. You don't need to think of having a subtask. Mendix connects this subtask flow to the main flow automatically. But if we work with this pattern, then we need Mendix to tell Mendix to actually do that. And that's what we do right here. So after we get this workflow, we say, hey, you are a child of the main workflow. That is one way that we do this. And likewise, we can connect these two together. Then subsequently, I'm saving those by adding them to a list and committing them. That's basically the second bit. Then what we now have is 10 workflows running that are connected to the main workflow, but how do we know when they end? Because that is one of the benefits of having this flow, that this branch here is automatically started once everything that is up here below is completed. Mendix does that for us. In the second way, we need to tell Mendix to continue with this main path. And we do that with a sort of a callback. So let's look at our second workflow, which is slightly adapted. So again, task 2. And then here at the end of every task 2 subflow, we do a little check. And it works like this. First off, we get the parent workflow. You know, the main one. So we have these 10 subflows and then we get the main one. That's what we do right here. Subsequently, what we do is we see if we can get all of the user tasks in the subflows. So the user tasks are right here. First off, the workflows in the subs, and then all active user tasks right within here. That's what we do with this query right here with an XPath constraint. So we can literally do that. If none are found, then we are done. So if we have found some, then we're basically saying, okay, not done yet. But if none are found, then what we can do is we can change the workflow state again, and we'll say unpause that main workflow. And then it will automatically continue. So this will work. And actually, to show you that we've done this right within our application, we've got both paradigms side by side. Let's see, SCM main. It's right here. So the first workflow has the 1, 2, 3, 4 multi-paradigm, and then onwards we go for the local flow where we have the 1 to the nth paradigm. So that's the second option. And then right within this exploration phase, when there is impact after the review, that is where we actually say, okay, if you complete this path, then we will start another global flow in the logic that is right within here. So that's a bit too much detail, but this is actually the first challenge. So I gave you 2 ways of properly doing that, multi-dimensional workflow modeling. Then the second one is how to model the context data. And a bit of a background on this. This initially started out with a quite simple workflow. It was not very difficult. The client said, yeah, it's just a simple workflow. We work together in Excel, that's it. And we started drawing it out, and it wasn't very difficult. But then it started growing. Can we have this bit, and can we have that bit? And turned out, hey, we actually have 4 explorations instead of 1. And hey, we actually have 10 tasks instead of just 1. And some of this I could actually sort of smell a long time away, but that is why we sort of started thinking again, how do you model the context data properly? Because if you do that right from the first get-go, then it starts to get easier. Because if you don't know that, then your model might look something like this. So where you think, okay, we have a supplier change notification with a number of steps. That's basically it. So we can capture all of the information for the steps right here and then have a single list. But then it turned out we could have 4 exploration groups, so we had to add this. And then it turned out we had to add tasks. And now actually we know that we're going to get subtasks as well, so we're going to make it more multidimensional. Anyway, it may be handy to have it like this, because you can actually see it, but it starts to get complicated really fast, and you need to duplicate yourself a lot of times. So you can reduce complexity by doing it like this. Let's see where this is. So this is actually a derivative of the composite method that is used a lot in Java. So it's a derivative because we can't actually do this exactly one-on-one in Mendix, but we can sort of somehow mimic it. So imagine that we have this main workflow, right? That has a number of subs, so steps to do. So a stem has leaves. So when can you use this composite? You can actually use it when your data looks like this. It's a hierarchy, it's a tree. So that's what you really see here. Because what can we then model? We can say, okay, a stem can have leaves, right? So a stem can have leaves, 1, 2, 3, 4, 5 leaves. But the stem might also want to have another stem, right? So that we can have 2 stems connected together with leaves, and then we get this hierarchy. And that we can do by using inheritance. So if we say that we have a composite, and we make stem a child of this composite, it inherits this list. So a stem can have a list of stem, 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 can have a list of leaf. But there it ends. So that's what we do with this model. And likewise, we can actually get an inheritance, a specification for each sub-workflow and or step. So we could have one specifically for a pre-assessment, for a review, and for global planning. And we don't have to model all of the stuff that we do each time when we call a sub-workflow, or we do a user task, or we want to know something about the position or parallel position, or how deep we are, etc. in the domain, in the tree. So that's what we can all generalize away. So we don't ever touch this, but we can actually make our own specifications for steps and reviews. And that's what we've actually partially done in our application already. And you'll be seeing some of the benefits of this in a bit when Cindy presents. So this is our advice. You can start working off of this, and you can actually download this later on to experiment with as well, if you like. So you can actually retrace these 2 paradigms and actually experiment with this domain as well. So yeah, let's round it off. So what are the benefits of having this composite derivative? You have a single domain model that is robust, and you could do deep branching there. So just adding a new step or a new flow, no problem. You just add another specification and you can go a level deeper. So flows become reusable, and specializing allows for as per task need tweaks. So for instance, if task 1 requires you to have 5 certain attributes, you can just add them for task 1, and you don't have to have them for all of the other ones. But be careful of the complexity of recursion, which is natural to multi-dimensional workflows. So a workflow in a workflow in a workflow. There is an inherent, a natural form of recursion in there. So make sure that your team understands this, because this will be difficult for the average Mendix developer. But if you do use this, then it is really well suitable for multidimensional flows. So let's go on to the third challenge, which is going to be presented by Cindy.
Okay, so the third challenge that we had was how do we show all of that complex data in a way that it's still understandable for the users. Now let me switch to the application. Here we have the historical data page, and on this page we show all of the data that has been filled in for this specific SCN or supplier change notification. Now when I scroll down, you'll notice that we show quite a lot of data on just this one page. Oh, let me just sit down first. But we've added some structure to it so that it's still easy for the user to actually find the data that they need. Let me start from the top. So the first section we have here is the general info section. Here we can find the data that has been filled in by the secretary when they need to create a new SCN or supplier change notification. Then the next one is where we can find all of the expiration phases. So here each phase is displayed in a column. So the first phase is from here up till here, and then starting from here we can find the second phase, the third phase, and so on. Now each step is displayed as a card. The first one is the pre-assessment step, and when I scroll down you'll see that the next step is a review. We have this connector line in between to indicate that these two steps belong to the same phase. And the same thing happens for the second phase, pre-assessment step, with all the data that has been filled in for that step. And then here, a review step as well. Now, you can see that the third phase is not fully visible in the viewport. And that's why we've added a horizontal scroll bar here at the bottom, or I can just drag here on top of the cards. The next section is for all of the global phases, and it looks almost identical, but the only thing that's different is that in the global execution step, we also have tasks in it. And that's why we've used a accordion widget so that we can display the task cards here separately. And when I collapse this one, you can see that the last step of this phase is the global closure. And then the last section is for all of the local phases, and it looks exactly the same as the global one. But here I have to mention that we can have even up to 10 phases. So that's why it's even more important that we have something like a horizontal scroll bar to go through all of that data. And that's basically it, how we've structured this page with 4 group boxes, and then we have some step cards and phases. Now let me go to the SCN step page. Here we can find a list view with all of the steps separately. So when I select the first pre-assessment step, you can see that the data here is displayed the same way as I've shown you on the previous page in those cards. And that's because we've used a lot of these data snippets. So let me show you how it looks like in Mendix. So here we have the step detail snippet, and we have a list view on this page. And in the domain model, as you may remember that Wouter has shown you, we use a generalization of the step main entity, and because of that we have step specializations, and the benefit of having that is so that we can use list view templates. So when I go to the list view and go to the templates tab, you can see that we have 7 specializations, each for each step, so that each step has their own template. Now, when I select, let's say, the template for the pre-assessment step, we have 2 snippets. The first one is a snippet for reassigning the task, and this snippet we use in every step. But the second snippet is specifically made for, well, to display the data that's only for the pre-assessment. Now, when I go to another step, you can see that the first snippet is the same one, but then the second snippet is data for the global action plan definition. Now, you may wonder, how do we even use a list view? Because we only show one object on each page. And as a data source, we have this small microflow where we pass the step object as a parameter. We just create a list of steps, and we add that step object to the list and return that list. And that's how we use a list view on this page. So the key takeaway that I'd like to share here is that by using a generalization of the step main entity, we have step specializations, and the benefit of having that is that we can use list view templates to show all of that data on this one page. And as a user, it doesn't really look that complex anymore, and in this way it's a lot easier to actually understand what's happening within these flows. That's it for the third challenge. Now let me go to the fourth, which is this one. How do we simplify the status of all these complex flows to something that everyone will understand in one view? Let me switch back to the application and go to this page. So you already have seen this table with steps, but let's just focus on the first 2 columns over here. So this pre-assessment has this green icon next to it. When I hover over it, you'll see a small animation triggered and the status name in the tooltip. So this icon is for the completed status. If I go to the next one, this one is for the in progress status. And here at the bottom, we have a pending status. And the reason why only these steps can have a pending status is because if I select the step, you can see that the global execution has 4 pending tasks in it. Now let me go to the home screen. And here we have the SCN overview. We currently have 4 SCNs in the system. And let me, the other steps only have 1 icon, but here you can see that each SCN has 3. And the reason why we show 3 instead of 1 is because we don't need to show all of the task and step statuses in an SCN. So that's why we've generalized all of these statuses into these 3 essential icons. So let me start with the one here at the bottom. You can see here that the exploration phase is in progress because there's only 1 pre-assessment step ongoing. And because it hasn't been finished yet, we don't know whether we need a global or a local phase. And that's why we have this unknown icon for the global phase and the local phase. Next up, we have this SCN with the expiration phase in progress. But let me show you this slide again to explain the SCN that I want to show. So global flows can start immediately once an expiration phase has been finished, but a local flow can only start when all of these expiration phases have been completed. So that's what's actually happening in this SCN, where we still have a expiration phase ongoing. Here we have a global flow, but we still need to calculate how many local flows there are, and that's why we have this pending icon here. The next one, you've already seen this pulsating status. It's an overdue status, and when I go into this SCN, you can see that it's inside a global execution. So this task is actually overdue, and we indicate it over here. What we can do in this situation is just contact the assignee of that task and just let them know that they need to complete their task as soon as possible so that the others can continue with the SCN. And here we have an expiration phase that's completed. With this grayed out over here, we show that there is no local impact indicated during the pre-assessment task. And the last SCN is the one that I've already showed you. So let me switch to Mendix and show you the flow that we use to update these statuses. So for the exploration phases, we retrieve a list of step groups that are in progress, in pending, or overdue. We check if all of the exploration phases have been completed. If they are, then we set the exploration status to completed. And if not, then we go down here, loop through all of the step groups again to check if they are overdue. Are they overdue? Then we set it to overdue, and if not, then we set it to in progress. Now the same thing happens for the global phases. Retrieve the step groups, check if they are completed, set it to completed status, and if not, we set it to in progress or overdue. Now for the local phases, it's a bit different, like I've shown you on the slides. We first check if all of the exploration phases have been completed. If they are not, we go down here and set the status to pending. But if they are, then we retrieve a list of the local step groups, check if it's completed, and it's actually the same logic that we've used for the other phases. So that's it for this microflow. And the lesson that I'd like to share here is that by using status indicators or icons, it's a lot easier for the users to actually follow the progress of a multidimensional workflow. And now I'd like to hand over back to Wouter.
Thank you very much. And I think that that's really interesting, that last bit where you can have literally 100 of active steps at the same time. So how do you keep track of that, right? So it's basically by using a drill down function or actually a propagate status upwards function. That's the way that we can do that. So let's see if I can quickly share again, and then we'll go to last little bit. Let's see. And if the screen, yeah, it's properly sharing. So these are the bits that we discussed. So first of all, How to model parallel subflows, right? So there are these two ways. So the multi-parallel flow and the 1 to the nth parallel subflow, if you remember. So how to model your context, use the composite pattern, derivative, and inheritance. How do you show complex data within flows? Well, you can use snippets and list view templates with that neat little trick where we passed a single object as a list, and then likewise we could use list views. Finally, how do you keep track of the status? So you use status indicators to visualize progress. And finally, there's one more thing. Hopefully sound will work, so let's see.
Hi, my name is Jongen. I'm product manager Workflow at Mendix, and in the next 10 minutes I will mention you two of the main new features that we will release in Mendix 10 regarding workflow. So Wouter has been talking with you about multiple workflows, user tasks that are executed in parallel and some of the complexities around it. So we have actually tackled some of those problems in the next release. So here I have a short slide summarizing those new features. So the first feature that we've added is multi-user task. That actually is a task that will be executed by multiple users, and they all need to do the same thing. So you can think about approving a request, signing off a document, etc. These are typical things that everyone needs to do in parallel, and everyone is doing the same thing. So as a developer, if you would like to start using this activity, you need to actually answer two questions. The first one is, who needs to execute this task? And that's very obvious, of course. And the other one is, when people need to make a decision, approve or reject something, how am I going to evaluate multiple outcomes from those people into a single outcome? So if 3 people need to make an approval, 2 of them approve and 1 rejects, how are you going to evaluate that into a single outcome? So we will talk about that in a minute. And the second activity that we've added is wait for notification. And wait for notification is suspending the workflow process and is waiting for an external trigger to tell the process that it can continue. So for this, we've added 2 activities. One of them is a workflow activity called wait for notification, and the other one is a microflow activity that tells this workflow activity that the workflow can continue. So it's a bit similar as the user task. The user task also stops the workflow, and then in an activity, you tell the workflow to complete that user task. So to show this more in action, let me go into Studio Pro. So here I have an example process how you would do it nowadays, so before release 10, so this is not release 10 process, this is how you would do it today pre-10. So for example, I have a request and it has to be approved by 3 people. So then I have to build 3 tasks. I have to store the outcomes of all those people, and at the end I have to evaluate actually if they all approve together, do they all have the same approval, there's only one approving and the other is rejecting, how to deal with that situation. In addition, at runtime I'm not able to make any changes to this number, so 3. In this process it's fixed. It could be that based on the complexity of the request, it's only 1 user. If it's about a high complex request that I have 5 users. So currently it's not possible to dynamically set how many users need to approve this request at runtime. So that's actually quite a complex thing for something very simple. So that's why we've added multi-user tasks. So actually this is the same process as you saw before, but now with the multi-user task. So the configuration of this task is very similar as for the single user task. The actual configuration capabilities are in the middle section. So of course you have your user targeting, where you say which group of users will receive this task in the inbox, and then you are defining how many of those users need to execute this task. So in the previous example, you saw that I would like 3 users to execute this task. It could also be that you have a percentage when you have a larger group, and you said you would like half of the group to make a decision. You set this number to 50%, and then the runtime engine will automatically calculate that of the 100 users, 50 need to execute the task. Then, of course, each user needs to make a decision, for example, in this case, approve or reject. And how are we going to aggregate all those different outcomes into a single outcome? And we do that using one of the decision methods that we have provided out of the box. So we have consensus, veto, majority, and threshold. They all have different meanings. In documentation, you can have examples, and it's clearly explained how this works. Consensus, for example, I will do it, just one example. Consensus, for example, means that everyone needs to come to the same conclusion. So in the example that we have here, it means that everyone needs to approve, or everyone needs to reject, or this task to have an outcome approved or rejected. Is there not any consensus? So for example, one person selects approved and another person selects rejected. It means is that there's not really a final decision possible, and then the task will be completed with a fallback outcome. So the fallback outcome is a kind of a more process-oriented outcome. It's not an outcome that the user can select, but it is an outcome that the runtime will select for you, so that you as a developer can define a escape action, so to say. What in case those three people are not in agreement? What would you like to do? Would you like have another group of people look at it? Would you like them to review it again? Would you like to have a manager be involved, etc.? So in this case, you have additional capabilities to make the process, to continue the process. What we will be adding later on is we will add the possibility that you can find your own decision methods as a microflow, and that you can have the evaluation done at the end. So now the evaluation done is at each task completion, so that we can also early on, as early on as possible, complete the process. But we can also add a checkbox that all tasks need to be completed before the final decision can be made regarding this activity. So this is the multi-user task. Then the next one is the wait for notification. So here I have again this very basic process where we have to order a few things that we requested, and we have a specific order application for that. So the process via API is handing over order to an ordering system. This can be done by business events, APIs. It could also be another workflow in the same application or another application. That's entirely up to you. And then the process is actually waiting for the ordering system to tell the process that the orders have been received, the goods have been received. So the process at this point in time is not doing anything, it just waits for a signal. And when the signal is received, I'm going to inform the requester that he can pick up his goods. So this activity, again, is in your toolbox, Workflow toolbox, and there's no configuration required here, so it's very simple to add. However, the triggering mechanism for this, that is a microflow activity. So I will now show you the microflow that is triggering this workflow. So in this case, for example, you will receive some kind of a signal, event, object, whatever from your ordering system that the orders have been received, and then likely it has an ID or has its number or whatever. And using this number, we will then retrieve the workflow instance that is related to that particular order. And once you have this workflow object, you can then tell the workflow with this activity to continue. And the configuration here is very simple. You need to have the workflow object so that the workflow engine knows which workflow instance is affected here. And then you can select which particular wait for notification item needs to be triggered so that the workflow can continue. It's very simple, as like I said, reduce task, or you select reduce task is set to be completed. And then the workflow will continue as soon as this activity is executed. This outcome of this activity is a Boolean, and this part, the second part of the microflow is optional, so you can leave it away. But it gives you a mechanism as a developer to understand this triggering. Did it really trigger the workflow to continue, or was it a misfire? So in case of a misfire, for example, the workflow was not really waiting for this activity to happen, then you can log it, you can add your own complexity, your own logic, you can signal an administrator, you can stop the whole process, whatever you like. but you have here a mechanism to identify this triggering mechanism worked, so the workflow was fired, or it did not work. So in a nutshell, so that's the way for notification and how you can pause the workflow and continue the workflow. And like I said, it's very diverse where you can use it. You can use it to wait for events happening in other applications in your application, same application, or in other processes. So you can also use it for inter-process communication and synchronization. So these are the two main features that we will be releasing in version 10 of Mendix. I hope that also Wouter will see that using those features, his application can become a bit more easier to develop and easier to understand. And I'm looking forward for him to kind of incorporate this into the application. Looking forward, what we will be adding later on in the year is we will be adding a few extra features. This extra feature, and I need to add a legal disclaimer for that, not set as stone what we're going to build, but it's very, very likely because it's very short term. These are two items. One of them is a better ways to deal with historical data. As you may know, the runtime engine throws away all the data as soon as workflows have been completed or activities have been completed. So as a developer, we would like to give you a good way and a very flexible way to build your own historical data, facility services, for example, to build dashboards or reporting, etc. So we'll give you a lot of freedom to build whatever is necessary regarding historical data. The workflow engine generates a lot of data, and as a developer, we will give you ways to deal with that data and build something nice with that data. The other activity that we're going to add is timer events. The timer events, again, we will implement it in two ways. One of them is that you can add it as an activity in your process, and then it will stop that activity for a certain amount of time or until a certain date, and then the process will continue. This is called an intermediate event, but we will also allow you to add it to an existing activity. So for example, think about the wait for notification we just had. You do not want to wait forever until the goods are received. Maybe in 1 week time, you would like to start escalating them. So by putting a timer on that wait for notification activity, and you set the timer to 7 days, it means that if this activity, wait for notification, has not been executed in the next 7 days, then the timer event will trigger, and then, for example, you can go into a process that goes into ways to escalate the ordering or to have a request where the order is, etc. So it gives you more flexibility again to have time-based processes. So in a nutshell, this is what you can expect in the next 6 months. Probably there are a lot of other smaller things coming up, but this will be the two main topics for the next 6 months. So I hope this was interesting. I also hope this was useful for you. So thank you very much for your attention. And by the way, once you start using those capabilities, I would be very interested to get your feedback. Was it useful? And where should we improve? So thank you very much, and hopefully talk to you soon.
Thank you, Paul. So again, if you'd like to give some feedback, you can actually send it to paul.jongen@mendix.com. He couldn't be here last in person because he was on holiday, as people might be during these days, right? So.
Hi.
Oh. So let's round it off. So we have a couple of new features here, especially Mendix 10, which was released today. So do check it out. It's actually in there. A multi-user task, which is a very nice addition, I think, especially if you have to do the same task, literally the same task 100 times or maybe 50 times, etc. That is where I think this one will come in really handy. And then wait for notification, which is also a nice addition, I guess. So that's it for today. If you have questions, we're actually here for you. So let's do a quick round, and then afterwards we can go downstairs and have drinks. Any questions? Aswin.
Where's the QR code?
Yes, thank you very much. If you scan the QR code, you will be able to access the slides and the Mendix project, I promised. So by all means, do grab your phone, store the link for later consumption, take a picture, and then later on take another phone and scan the QR, well, etc. By all means, go ahead and do that. Thank you. Any other questions? No questions. Is anyone considering building a workflow application with Mendix? Were you able to get some answers here tonight?
Yeah, I think it's cool, but hard to say if it is applicable.
Okay.
Too complicated to explain.
Okay. Well, maybe let's have a chat downstairs a bit.
Yeah.
Anyone else? Yeah. Yeah. At task level. So basically, what you can do is you can have an assignment for users based upon next path. So a specific security role, or you can even extend that. So in our case, we literally have very specific user groups that we're targeting. Let me show you an example. In this one, operation. So let's say for the pre-assessment, we have an assignment flow which grabs a list of users. What we're doing here is we're finding specific users with a user role QM who belong to a certain stream in this case and who are active. So likewise, we can literally decide to the attribute level precisely what users we want. And the same we can actually do with the data. In this case, our application, all data was accessible to all users. So everyone can read, but only very small amounts of people can write. And in this case, you can only write when you actually are assigned to a user task. And once that's complete, then you're no longer assigned. And basically that means that the data becomes stored and is solid. Yeah. Yeah?
What would be the advantages of using the workflow engine over building your own workflow process using
microflows? Yeah. Good question. So just to recap, so what's the benefit of using Mendix Workflow over using traditional tools like your own modeling via microflows, etc.? I think that Mendix Workflow has come to fruition a lot. So I think it came out about 2.5 to 3 years ago, and at that time it was still somewhat limited, but it really grew over time. About 3.5 years ago, I personally finished on a workflow project in which we did everything manually, everything. And I can tell you that the logic for something like that can run out of control pretty quickly. And so all of the managing of tasks, someone getting that notification, or actually not the notification stuff, but having a bit of logic to which you can add a notification, that is already all there. So that saves a lot of time. Yeah, at least in my opinion.
quite interesting because we've got quite many swaps here, many users.
Yeah.
How do you look at that difference? We do have pioneer, we do have findings.
No one.
Maybe you're both experienced in many departments in Belgium, so I'm quite interested in your thoughts.
I think people want to go for drinks. Well, maybe we can answer that question downstairs. Shall we do that then? Yeah?
I do have a question.
Yeah?
So, love the fact that you call it challenges, because a problem is not really a problem, it's something that
To solve.
to solve. Yeah.
Exactly.
And it's a negative, but the challenge. What was the favorite part of the workflow module that you had to use, or that you wanted to use, that you did use to solve one of those challenges?
Actually, for us, one of the main issues while constructing this whole application was visualizing inside our heads how we're going to present all of those data. And it literally took us a couple of weeks to get up with a proper idea, then we had literally an iterative design. So we did a sort of blueprint, and then we made a couple of steps to look nice, and then we said, okay, now we need that there as well, and then we need this there, and etc. So over, I think, a period of 8 to 10 weeks, it literally went from being a very long page to something really nicely condensed. And if you understand the structure and you're aware of how the program works, then it becomes very easily legible. And also the drill down function, right? If you start from the dashboard and you see that overdue status, that you can drill down to the task where the issue is at hand. That is really, it took us some time to build that, but I think it's a really nice addition. So in a perfect world, I'd say, Mendix, please add automatic overdue status setting to workflows, right? Because we had to construct that on top of workflow. But maybe that's something that they'll do somewhere at the end. I'm not sure. It's an ever-evolving system, obviously. Yeah. Okay. Drink time. Thank you very much for coming. I'd love to answer your question downstairs. Right.
Before leaving.
And for Cindy as well.
As you're from the Netherlands, I'll give him the choice.
What's the choice? Could you explain?
This is a brown beer. It's actually almost the exact same recipe as Westvleteren. And this is is a blonde beer that's pretty nice also.
Okay. The blonde one.
Okay.
Thank you very much.
I do think it's a bad choice.
Oh, okay. It's good that she gets the good one then. Very much appreciated. Thank you very much
for being here. You're all also more than welcome later to drink something with us. We have the whole thing for up to 1 o'clock in the morning, but only drinks for 1 hour as soon as we start here. I still want to